Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hasriza binti Muhammad Rizal. My matric number is 1715958. And my title for final year project is Finding Elements, Code Developments of Timoshenko beam. My supervisor course is Associate Prof. Dr. Evan Sulaiman. The content of my slide is first objectives, second is introductions, and then literature, and lastly is a methodology. The main objective of this final year project is to develop a software that can analyze a deep beam structure by using finite element method based on Timoshenko theory. To analyze the behavior of beam structure, we can use two theories. First is the Euler-Bernoulli theory, and the second is the Timoshenko theory. However, they have difference of these two theories. For Euler-Bernoulli theory, the shear deformation and the rotational effect is neglected. However, for Timoshenko theory, these shear deformations and rotational inertial effect is considered. As we can see here, this is the beam structure before moment being applied, and after the moment being applied, this is the deformations of the beams, and this is the for the Euler. The red one color is the for Euler-Bernoulli theory, and the blue color one is for the Timoshenko theory. We can see that for the Timoshenko theory, the shear deformations and the rotational effect are being considered. Usually, Timoshenko beams be used for thick or short beams and sandwich composite beams. And for under a static loads and buckling, Timoshenko beams have a lower stiffness compared to the Euler-Bernoulli beams that result in a larger deflections. Next literature review. Both of the articles study about the railway track. Zhang and other authors on 2020 study about the railway track that's supported by a moving loads. And turns out for high frequency, Timoshenko beams and Euler-Bernoulli beams show a different result, which is for high frequency, Timoshenko beams show a more accurate result than compared to Euler-Bernoulli beam. But for the lower frequency, both of the theories show the same results. And for demand theory, it uses the pin-pin resonance same as the Zhang's and other author, and it uses the finite elements method of track in the frequency domain based on the Timoshenko beam elements. For me, this both article is good because for Zhang is compared between the Timoshenko beam and Euler-Bernoulli beams. From there, we can see the difference between both theory. And then it's also good, we can see the usage of Timoshenko beam using the finite element methods. Next, Laura Bryant and other author on 2014. This article is about the Timoshenko beam element that have been developed based on modified coupled trias theory. For me, this article is not good because it is modified from the coupled trias theory, which does not link with my projects. And the second is Ali Fahidas on 2017. This article is about the unified formulations of the shear coefficients in Timoshenko beam theory. For me, this article is good because it's helped me a little bit in terms of the shear. Next is a Hutchinson on 2001. This article tells about the shear coefficients of Timoshenko beam for circular and rectangular cross projections. And for Blue and another author on 2014, this article is about telling about the new finite element for Timoshenko beam to obtain ultimate limit loads for reinforced beams. For me, both of the is good because it shows the use of the Timoshenko beams. Next, Zhao and other author on 2019. This article is about partitions of linearity finite elements method for modeling of Timoshenko beams, and it used uniformly distributed harmonic loadings. And next is the Ismail Hassan on 2020. This article is tell about the limit of size dependence Timoshenko microbeam, and it used a moving loads. For me, for Zhao and other author, it's not a good article because it uses the partitions of linearity finite elements, which is different from my projects. And for Ismail Hassan, for me, it's good even though the Timoshenko beam that have been used is a Timoshenko microbeams. for me, it's really a good articles. Next, research methodology. Among all the articles that I have been read, the research problem question that have come up is how to develop a coding that can calculate the deflections of Timoshenko beam theory. Therefore, for this project, I developed a codings using a MATLAB in order to investigate the deflections of the beams and validate it with the exact result. Here is the process for the project. First, we start with defining the parameters, and then we develop of a codings, and we validate the results with the exact result. This is the end of the project. Next procedure of this project. First, I'm using a distribution loads and then simply supported Timoshenko beams. And then the variable, independent variable, are using rotational angle and deflections. In functions of moment inertia, shear modulus, Young modulus, length, and area of the cross sections. After I have defined all the parameters, I deriving and calculated by formula that also using the finite element formulas. And then after I got the formulas, I write the codings with the parameter that have been defined. After that, I get the results and compare with the research paper. If the result is the same and valid, I use the same coding but difference parameter that according to the beam parameter to calculate the deflection. That's all for me. Thank you.